Five intersections of lines and planes. So if we have a line and planes, there are three situations. In a line passing through the plane at one point, when a line is just on the plane, so means there is infinite number of solutions. Or when the line is parallel to the plane and hovering about it, no solution. But this is general things we can substitute parametric equation of the line in the scalar equation of the plane, and then we look at the t. If the t is, we have one value for t, we have one solution, one point of intersection. If there is no solution for t, would be the one that is hovering about, and either if the 0 equal to 0 means we have infinite number of solutions. Let's just look at an example here. Also, if you want to quickly check if a plane and a line is parallel or not, because here is when we have plane, the n is defined, right? The n gonna be a perpendicular vector to your plane, and there is a line here. If this line is parallel to the plane, the directional vector m and n is perpendicular, right? Means the dot product between them is 0. If the dot product is 0, these two are parallel. But if it's not 0, you have one point of intersection. So the example here is a plane 9x plus 13y minus 2z equal 29, and the parametric equation of the line is given to you. So instead of the x here, you put 5 plus 2t. Instead of y here, you put negative 5 minus 5t. Instead of z, you put 2 plus 3t. Then you just simply, when you sub it, expand it and solve for t. So when we have t, there is going to be one point of intersection. You just select the p here. For p, you put -1 everywhere. So you just calculate for x, y, and z, and 3, 0, -1 will be the point of intersection. So here is another example. You have a line, the equation of that, and we have a standard equation of the plane. So you need to write this one in parametric. So x is equal to 1 plus -2, 1 plus -2. So it's 1 minus 2t. Y equal to 0 plus t. So it's t. Z is 1 plus -4t. 1 z is 1 plus -4t is then minus 4t. Now here in this equation, we just have x and z. Instead of x, we put 1 minus 2t. Instead of z, we put 1 minus 4t. We solve for t. We see 0 equal to is impossible. So there is no solution. So another way to do this question, so the directional vector, this is m, is -2, 1, -4. And you know the ABCs will give you the normal vector to the plane. So it's going to be 4, 0. We don't have quotient for y, so it's going to be 4, 0. -2, it would be normal to the plane. So you dot product them. It is 0 means these two are parallel. But are they parallel? It could be coincide. To check that, I find a point. Here is the point on the line 1, 0, 1. If this point is on that, so it is. Both are coincide, but if it is not, so they are just parallel. So I put 1, 0, 1 into the plane. This is from the line, so I put it in the equation of the plane. I get right side equal not equal to the left side. It means this is just hovering about this line and the plane is not coincide. Here is the equation if you want to find the distance between a point and a plane. So here is the plane that you have. Question P is a point. You want to find the distance between the point and the plane. Of course, the distance is going to be perpendicular distance, right? So you need to have a Q, any point on your plane. And you know the N going to be a perpendicular vector, vector to the plane. So you find the vector PQ and you dot product that to the N and dividing by the magnitude of the n. So let's just do a question about that. So find the distance between the point and the plane. So 4x plus 2y plus z minus 16 equals 0 is the equation of the plane, and the point 10, 3, -8. Okay, we have a point and we have a normal vector is coefficient of the x, y, z. 4, 2, plus 1 is your n hat. Now I find any point on the plane, right? I can put x and y 0 and find z. You put x and y 0, you find z is 16 here. So the q is 0, 0, 16. Now I need to find pq. pq is second point minus first one. So q minus p, so 0 minus 10. 0 minus 3, 16 minus minus 8. You do that. This is the PQ. Then dot product of the N and PQ divided by the magnitude of the N. The magnitude of N is just the x component power 2, y component power 2, z component power 2 square root here. You, for dot product, x component multiply x component, y component multiply y component, z component multiply y component, and you add them together. So this will be the answer, which is 4.8. For the question, you can do question number 1, question number 2A, 3A, 4A, 5A, 6A, 7A, 8A, question number 9, 10A, and 11A.